NASA's Europa Clipper radar instrument successfully tested at Mars. In a groundbreaking test, NASA's Europa Clipper has successfully demonstrated its radar capabilities during a flyby of Mars. The results are a promising sign for the mission's ultimate goal, investigating Jupiter's moon Europa. The Reason radar instrument, designed to penetrate Europa's icy shell and potentially detect an ocean beneath, performed flawlessly as it bounced signals off Mars's equatorial region. This critical test, impossible to conduct on Earth, proved the radar's readiness for the challenges ahead. Every part of the instrument proved itself to do exactly what we intended, said Don Blankenship, principal investigator of the radar instrument. But here's where it gets even more exciting. The radar will not only help scientists understand Europa's subsurface structure, but also how materials from the ocean may be transferred to the moon's surface. And this is the part most people miss. Europa Clipper's radar setup is highly unusual for an interplanetary spacecraft, featuring two pairs of antennas that extend from its massive solar arrays, which are the size of a basketball court. While extensive testing was conducted on Earth, the Mars flyby provided a unique opportunity to calibrate the radar instrument over familiar terrain. As the spacecraft zipped by Mars, Reason collected a trove of data, giving scientists an early chance to refine their understanding of the instrument's behavior. The engineers were excited that their test worked so perfectly, said Trina Ray, Europa Clipper Deputy Science Manager. Now the science team is getting a head start on learning how to process the data and understand the instrument's behavior compared to models. As Europa Clipper continues its 1.8 billion-mile journey to Jupiter's icy moon, the mission's success could revolutionize our understanding of habitable worlds beyond Earth. Oh, what do you think? Could Europa be the key to unlocking the secrets of life in our solar system? Let us know in the comments below. NASA's impossible feat, radar breakthrough on path to Jupiter's icy moon, Europa. NASA's latest radar technology has achieved a remarkable feat that many thought was impossible on Earth. In a groundbreaking event during a close flyby of Mars, NASA's Europa Clipper spacecraft successfully tested its radar system, known as Reason, for the very first time in the vastness of space. The flawless operation of this radar system has left scientists exhilarated, as it effectively bounced signals off the Martian surface. This accomplishment not only demonstrates the radar's readiness to explore Europa's icy shell for potential signs of a concealed ocean, but also resulted in the collection of 60 gigabytes of data. This data not only confirmed the reliability of the hardware, but also provided researchers with an invaluable opportunity to refine their analytical tools ahead of the Clipper's anticipated arrival at Jupiter's icy moon in 2030. Success of the Mars flyby radar test. In March, as the Europa Clipper spacecraft made its way past Mars, it conducted a vital radar test that could not have been executed on Earth. After thoroughly analyzing the complete dataset, mission scientists were pleased to announce the test's success. The radar system functioned precisely as intended, transmitting and receiving signals from the vicinity of Mars' equator without any complications. The radar, aptly named Reason, Radar for Europa Assessment and Sounding Ocean to Near Surface, is specifically designed to penetrate beneath the surface of Europa, which is Jupiter's fourth largest moon. Scientists are optimistic that it will uncover pockets of water trapped within the moon's thick ice shell, and may even confirm the existence of the vast ocean believed to lie beneath. Reason. Investigating Europa's icy shell. We achieved everything we hoped for from the flyby, expressed Don Blankenship, the principal investigator of the radar instrument at the University of Texas at Austin. Our objective was to assess the radar's readiness for the Europa mission, and it performed flawlessly. Every component of the instrument demonstrated its capability to fulfill our expectations. The data collected from the radar will assist researchers in exploring how materials from Europa's subsurface ocean might ascend through the ice to the surface. Additionally, it will enable scientists to analyze surface features such as ridges and investigate how these connect with structures identified beneath the ice. Limitations of Earth-based testing. The Europa Clipper features a unique radar configuration for an interplanetary spacecraft. Reason employs two pairs of slender antennas that extend from the solar arrays, covering a span of approximately 58 feet, 17.6 meters. These solar arrays are massive, comparable in size to a basketball court, allowing them to capture as much sunlight as possible at Europa, which receives only about 1/25 of the sunlight that Earth does. Prior to the spacecraft's launch from NASA's Kennedy Space Center in Florida on October 14, 2024, the instrument team conducted all feasible testing. During the development phase, engineers at the Jet Propulsion Laboratory, JPL, in Southern California even took their work outdoors, utilizing open-air towers on a plateau to stretch and test engineering models of the instrument's delicate high-frequency and compact, very high-frequency antennas. However, once the actual flight hardware was constructed, it had to be kept sterile and could only be tested in a controlled environment. Engineers utilized the expansive High Bay 1 clean room at JPL, where the spacecraft was assembled, to test the instrument piece by piece. To evaluate the echo or the return of Reason's signals, they would have required a chamber approximately 250 feet, 76 meters, long, nearly 3/4 the length of a football field. Mars Gravity Assist and Data Bonanza. The primary objective of the mission's flyby of Mars on March 1, less than 5 months after launch, was to harness the planet's gravitational force to adjust the spacecraft's trajectory. However, this flyby also provided opportunities to calibrate the spacecraft's infrared camera and conduct a dry run of the radar instrument over terrain that NASA scientists have been studying for decades. As the Europa Clipper sped past the volcanic plains of the Red Planet, descending from 3,100 miles, 5,000 kilometers, to just 550 miles, 884 kilometers above the surface, Reason transmitted and received radio waves for approximately 40 minutes. In contrast, at Europa, the instrument will operate as close as 16 miles, 25 kilometers from the Moon's surface. This animation illustrates a 360-degree view of NASA's Europa Clipper spacecraft, highlighting its scientific instruments. Reason delivers 60 gigabytes of valuable data. In total, engineers successfully gathered 60 gigabytes of rich data from the instrument. Almost immediately, they recognized that Reason was functioning optimally. The flight team scheduled the complete dataset for download, commencing in mid-May. Over the following months, scientists eagerly examined the information in detail and exchanged insights. The engineers were thrilled that their test was executed so flawlessly, remarked Trina Ray, Europa Clipper's deputy science manager at JPL. Everyone who had dedicated so much effort to make this test a reality, along with the scientists witnessing the data for the first time, was overjoyed, exclaiming, "Oh, look at this! Oh, look at that!" Now, the science team is getting a head start on learning how to process the data and comprehend the instrument's behavior in relation to models. They are honing their skills just as they will need to at Europa. The total journey for Europa Clipper to reach the icy moon will span approximately 1.8 billion miles, 2.9 billion kilometers, and will include one more gravity assist, utilizing Earth, in 2026. Currently, the spacecraft is about 280 million miles, 450 million kilometers, away from Earth. More about Europa Clipper. Europa Clipper represents NASA's ambitious mission to investigate Jupiter's icy moon Europa, which is considered one of the most promising locations in our solar system for the search for signs of life. Scheduled to arrive in the early 2030s, the spacecraft will conduct nearly 50 flybys of Europa, employing a powerful array of instruments to explore the moon's ice shell, subsurface ocean, composition, and surface geology. The mission has 3 primary scientific objectives. 1. Measure the thickness of Europa's ice shell and evaluate how it interacts with the ocean beneath. 2. Analyze the moon's composition, searching for organic materials, salts, and other essential ingredients for life. 3. Characterize surface features and geology, aiding scientists in understanding the moon's dynamic history. By conducting a comprehensive survey of Europa, this mission will help assess the habitability of this ocean world and broaden our understanding of potentially life-supporting environments beyond Earth. Led by NASA's Jet Propulsion Laboratory, JPL, in Southern California, and managed by Caltech for NASA, Europa Clipper involves key partnerships with the Johns Hopkins Applied Physics Laboratory, APL, which designed the spacecraft body, along with NASA's Goddard, Marshall, and Langley centers. The radar instrument, REASON, is spearheaded by the University of Texas at Austin, and the spacecraft was launched under the guidance of NASA's Launch Services Program at Kennedy Space Center. This nationwide collaboration is paving the way for one of the most thrilling planetary science missions of the decade. Stay updated on groundbreaking discoveries. Subscribe to the SciTech Daily newsletter. Europa Clipper's Mars flyby success. Radar ready to hunt for life on Jupiter's moon. Imagine a spacecraft embarking on a monumental journey to uncover the secrets of one of Jupiter's moons, Europa. But here's where it gets exciting. NASA's Europa Clipper recently passed a crucial test during a close encounter with Mars, ensuring it's ready to tackle its primary mission. This event marks a significant milestone in our quest to find signs of life beyond Earth. Launched in October 2024, Europa Clipper is on a 1.8 billion-mile, 2.9 billion-kilometer voyage to explore Jupiter and its moons. On March 1, 2025, it performed a carefully planned gravity assist maneuver, flying within 550 miles, 884 kilometers of Mars' surface. This maneuver wasn't just about adjusting its path. It was also a golden opportunity to test the spacecraft's instruments in deep space conditions. One of the star players in this test was the REASON, Radar for Europa Assessment and Sounding, Ocean to Near Surface instrument. This radar system is designed to penetrate Europa's icy crust and reveal what lies beneath, potentially liquid oceans and the possibility of extraterrestrial life. During the Mars flyby, REASON sent and received signals that reflected off Mars's volcanic plains without any issues, producing approximately 60 gigabytes of data. "We got everything out of the flyby that we dreamed of," said Don Blankenship, a research professor at the University of Texas at Austin and the principal investigator for the REASON instrument. Every part of the radar system worked precisely as intended. REASON operates by transmitting radio waves that bounce off structures within Europa's ice layer. To achieve this, it uses two pairs of slender antennas mounted on the spacecraft's expansive solar arrays, which span about 58 feet, 17.6 meters. These arrays are as large as a basketball court, designed to harness as much sunlight as possible in Europa's dim environment, where sunlight is only about 1/25th as strong as on Earth. Testing such a sophisticated system posed challenges. Engineers at NASA's Jet Propulsion Laboratory, JPL, conducted extensive outdoor tests using towers on a hilltop above the lab. However, the final flight hardware had to remain sterile and was tested indoors, limiting full-scale trials. A proper echo test of the fully integrated system would have required a chamber nearly the length of a football field, a feat that made the Mars flyby the first chance to test REASON in its complete operational form in space. According to Trina Ray, the deputy science manager for Europa Clipper at JPL, the excitement was palpable. "All of us who had worked so hard to make this test happen, and the scientists seeing the data for the first time, were thrilled," she said. "It was like Christmas morning for us." The spacecraft is currently about 280 million miles, 450 million kilometers from Earth, and is scheduled to receive another gravity assist as it swings around Earth in December 2026. Its ultimate destination is the Jupiter system, where it will begin a 40 flyby mission of Europa in 2030. This mission raises intriguing questions. Could Europa's subsurface oceans support life as we know it? What unique conditions exist beneath Europa's icy crust? These are the kinds of questions that Europa Clipper aims to answer, making it a pivotal step in our exploration of the cosmos. What do you think? Are you excited about the potential discoveries from Europa Clipper? Share your thoughts and theories in the comments below.